Alabama STEM Explorers is made possible by the generous support of the Hudson Alpha Institute for Biotechnology, Southern Research, solving the world's hardest problems, the Hawley Family Foundation, Alabama Works, Alabama STEM Council, Alabama Mathematics, Science, Technology, and Engineering Coalition, Alabama Math, Science, and Technology Initiative.
Have you ever wondered what makes things fly? Does a bird need something different than a paper airplane? And what makes those heavy jumbo jets stay up in the air? I think I know who can help us figure this out. Welcome to Alabama STEM Explorers. This is actually my first time in an airplane. So where are we headed?
Actually, we're going nowhere. But I'm Tim, and this is Cruz and Jessica Warder, the Director of Education at FlightWorks in Mobile. And we're hoping that she explains to us more about how airplanes stay in flight.
Are y'all ready to learn?
Yeah.
All right, let's go. All right, Cruz, so you've never been on an aircraft before. So
No,
are you
I
ready?
haven't.
You haven't?
Yes,
all
I
right.
am ready.
So you are ready to learn all about it, because I'm sure you're wondering what keeps an airplane up in the sky, or what causes that rocket to take off, or even when you're outside flying your kite, what causes it to lift off that ground?
Yes.
So, all right, we're gonna start off with the how things fly, and we're gonna talk about the 4 forces behind flight. Do you
Okay.
know what a force is?
Yes, it is from Star Wars, when you lift rocks with your hands.
Absolutely. Completely agree with that, but do you know a little more of the science behind force?
It is a push or a pull.
Okay, perfect. So there are actually 4 forces when it comes to flight. You have that drag, you have that thrust, you have that lift, and that weight. We're gonna start off, and we're gonna dive a little deeper into all of them, but we're gonna start off with weight. All right?
Okay.
Are you ready? Okay, so I have an experiment for you. What I want you to do is take both of these balls, all right? Tell me what you notice about them.
The baseball is heavier than the tennis ball.
Okay. Anything else?
They're different sizes.
Okay. But they're kind of the same size in a way. One's a little just smaller.
Yeah.
All right. So what we're going to do is we're going to see what happens when we drop these 2 balls at the exact same time. All right?
Okay.
So let me make sure that we're nice and even. Perfect.
Here we go.
Are you ready? You want me to count down?
Yep.
All right. 3, 2, 1. Whoosh. All right. So what did you notice?
They both touch the ground at the same time.
Okay. So do you know why? Or do you know why that might happen?
I don't.
So we're gonna just see if something, we're gonna use another experiment to see, because when you experiment more and more, you learn more. So we're gonna just kind of change the experiment a little with this one. With paper, all right, not balls, but 2 pieces of paper. What I want you to do is take that piece of paper and crumple it up and make it kind of in that ball shape.
Okay.
All right. You got it?
Yep.
All right, so I'm gonna put this ball, crumpled up ball here, all right, and this one in here. Now, these are the exact same pieces of paper when we started, right? Now, does anything feel a little different about them?
This one is a ball, and this one's flat and thin.
Okay, so what do you think is gonna happen when you drop these?
This one's gonna touch first, and this one's gonna go very slow,
Why do you think that?
because the air in between the ground and the paper just goes between it.
Awesome, all right, so let's see if you're right. I love a good prediction.
Here we go.
All right, ready?
Yep.
Let me give you the nice countdown. 3, 2, 1. You are absolutely correct. Awesome. So, why do you think we did this experiment? We're talking about weight. So, what do you think this has to do with an aircraft?
I don't know. What is it?
All right. Well, the weight is what's going to pull that aircraft down, like that gravity is what's holding on. Because, if we jumped, we'd land right back on the ground, correct? That's because nothing's going to lift us up, because gravity is constantly pulling us. So we have to fight against that gravity to push things up with the aircraft. And that's something that we do here at FlightWorks every single day. All right?
Yeah.
So we have that force of weight down. there's always an opposite force. Do you know what
lift.
Yes.
Because you always have to have an opposite, because if you only had weight, it would go straight down.
Yes, clearly, because we don't get up, do we? All right, so let's learn a little more about lift. All right, so now that we know about weight, let's go in that opposite direction. Do you remember what it was called?
Lift.
Yes. So lift is what's going to hold that aircraft in place. All right. So we're going to dive a little deeper into Bernoulli's principle. So what I'm going to get you to do is pick up this fancy tool right down here. All right.
A hairdryer.
A hairdryer. And I know that we both have fantastic hair, but that's not what this is going to be used for. So what we're going to do is we're going to see what happens when you turn it on. Because as you know, there's air all around this air dryer. Am I correct?
Yes.
So, but what happens when you turn it on? I know you've used one of these before.
It blows out air.
It blows out air. Now, is this air like faster, or is it slower than that that's going to happen around it?
It's faster.
It is. So what I'm going to challenge you with, and I'm going to see if you can take this ball and balance it on that airflow. Are you ready?
Yeah.
All right. Go. All right. Keep going. Awesome. Now, try and tilt it different ways. See how far you can go. Okay? Tilt it that way. See if it does the same thing. Awesome. All right, now. Perfect. Now, what happened? Tell me about it.
The gravity going down with the gravity going up, or the wind going up, it stood in the same place.
Yes. So you're balancing that force. You have that gravity that's pulling you down, and then you have this air that's pulling, that's trying to get you to come up. So you have that nice little balance in between.
So what does all this have to do with the aircraft?
All right. Well, this aircraft is actually an A320 Airbus, which, since you've never been on aircraft before, is something that we actually build right here in Mobile, Alabama, in our backyard. But when it comes to talking about where did they come up with these ideas with the A320 and such, we go all the way back to nature's aircraft, which are birds, which is, they used to look up at the sky all the time and observe different birds and how they would fly. And that's how they took this and they bundled it up in their brains and used it to create aircrafts. So on part of a bird, what part is going to help it fly?
The wings.
Wings. And that's probably why we cannot fly.
Yeah.
That's why we need aircrafts. So when we have these aircraft wings, or these airfoils, this is going to be the biggest thing that's going to help this aircraft lift up. All right. So what are some things that you notice about this airfoil? There's
an angle right here. There's this thing right here.
This is a sharklet.
Okay.
All right.
There's a tilt.
There is a tilt. So I want you to think back when we had that blow dryer and we had that ping pong ball and we were flowing it different ways. Where was the air pressure the lowest?
The top?
Yes, you're absolutely correct. And that is because the air is flowing faster at the top, which is going to cause that pressure to get lower. And it's going to go slower here, which is going to cause it to go, the air pressure to go up, which is going to cause that aircraft to lift up.
Yeah.
All right.
Okay.
So now we know more about weight and we know about lift. You want to dive deeper into drag and thrust?
Yeah, let's go.
All right, here we go.
As cabin installers, our main responsibility is the furnishing of the aircraft interior while it's on the final assembly line. This requires us to focus on specific areas of the aircraft, such as the main cabin, cockpit, or cargo bay. We install interior cabin components like the galleys and lavatories, which are pre-assembled, and we make all the necessary electrical, water, and other system connections. We also install the cabin doors, overhead bins, bulkhead walls, ceiling and wall panels, and floor covering. Pretty much everything but the seats, which happens later. So that means we're lifting and carrying up to 30 pounds, working with a wide range of tools, and have to be fit enough to squat, kneel, push, and pull as needed to get the job done right every time. Cabin installers also handle the installation and testing of electrical units and components, like the in-flight entertainment system, and often inspect the work of other team members to ensure all components and systems are properly installed prior to customer inspection. We are always looking for ways to eliminate work disruptions and rework to keep the assembly process moving along safely and efficiently. This means maintaining legible and accurate documentation and always following safe work practices like wearing personal protective equipment when working with tools, bonding agents, fasteners, or other specific tasks. To become a cabin installer, you need to have a high school diploma or your GED, as well as 3 years experience installing aircraft interiors or equivalent experience in another industry. However, experience and education requirements may vary. There are lots of roles that make assembling an Airbus commercial aircraft possible, and cabin installer is definitely one worth considering for your future.
All right, so we had a nice conversation about those opposite forces of lift and weight. So now let's go into those two final forces of drag and thrust.
Yes, okay.
All right, so we're gonna start off with a fun experiment on drag. All right?
Okay.
So I hope you brought your running shoes because I have you doing some physical activity for this one. All right, so what you're gonna do, I'm gonna have you go all the way to the top of that ramp, and then you're gonna come running back full force, okay? And while you're doing this, I want you to think, what do I feel? What's happening? So just while you're doing that, think about those things as you're running.
Okay.
All right?
Yep.
All right, so what he's gonna do is he's gonna come down here and run full force. And if you notice, he doesn't have anything this time. It's just his body running against the air. All right? You ready?
Yep.
In 3, 2, 1, go.
Yeah.
Woo! All right, 3 seconds. So let's talk about what did you feel as you took off running?
I felt wind.
Okay, wind, what did you feel? Did it like coming at your body? What did you feel?
Going like past me.
Okay, so do you feel like it was like holding you back, or were you fighting against anything almost?
No.
Okay, so you kind of felt like it was really smooth.
Yes.
Now, they still have that resistance when it comes to like fighting against you when it comes to this drag. But I'm gonna add a little more drag just to see if it's gonna slow you down or speed you up, all right? So this time we're gonna do the exact same thing, but I want you to come back. There's 2 umbrellas up there already open. You're gonna kind of use them where they're just gonna come up behind you. You're gonna take off, perfect. You're gonna take off running with these 2 umbrellas, all right?
Okay.
And it's the same thing. I want you to think about the same thing, what's happening.
Okay.
All right, go. So I'm gonna time him again when he comes down. This time he's gonna have those 2 umbrellas. This is gonna cause a bigger surface area, which is gonna cause a lot more resistance. So he should slow down. All right. You ready? 3 seconds last time. Let's see what we can do this time. In 3, 2, 1, go.
Ooh.
Whew. All right. Whew.
Whoa.
I felt the wind on that one. So that one took you 5 seconds. So tell me some of the things that you're feeling as you were running with the umbrellas this time.
Well, the umbrellas, because it is cupped, I guess it is blocking the wind from getting anywhere, basically.
So as you feel that wind or that air going around you, you feel like it's getting cupped, so it's kind of slowing you down. So did you feel more pressure going this way, like you couldn't catch and get that run? Yes, that is exactly what drag is. It's that air resistance against something that's going through that solid or that gas.
Yeah.
So how do we like overcome drag? What's the opposite? What do you just think?
Thrust.
Thrust. So now we're gonna learn how to overcome that drag with thrust.
Okay.
All right, so we talked about drag. Now we're gonna talk about that opposite force. Do you remember what it's called?
Yes, it's called the thrust.
Yes, so I have an experiment for you. It's our last experiment. So what I want you to do is grab those balloons that are underneath.
Okay.
And what you're gonna do is you're actually gonna pump them full of air. We're just gonna do one at the moment. And you don't have to put a lot of air in it, just enough to see, we're gonna see what happens when we let it go.
Okay.
All right. So just like 1, 2, 3, 4, 5. Perfect. All right. So you have that air inside the balloon, and now you're holding it in there. So what do you think is going to happen when I tell you to let it go?
The air is gonna go this way.
Okay.
And the balloon is gonna fly like that way.
Okay, so let's see. Are you ready?
Okay, ready?
In
Here we go.
3, 2, 1, go. Perfect.
Huh.
All right, so did you feel the wind on you, that air
Yes,
coming?
I did.
And the balloon went complete opposite direction. All right, this one, because when you experiment, you want to make sure that you do it a couple of times. We're going to do it twice, but this one, I just want you to put a little more air in there just to see if
Okay.
it'll go a little further distance.
Yeah.
All right,
Okay.
perfect. Little bit bigger.
Yeah.
Let's see if we can get it to go far. All right, perfect.
Oh, this is
you
a
want
big one.
Well, I know. I was like, you're not kidding with this one. All right, so we're gonna do the exact same thing.
Yep.
All right, in 3, 2, 1, go. All right, so that one did the same thing. You had that airflow coming this way, and it caused it to take that balloon
Yes.
this way, which is why we're standing in front of this big engine right here, because this is what's going to get that thrust on that aircraft. So all of those turbines are like, they're going to suck in that air, and it's going to push it out the back, which is going to do exactly what that balloon did. It's going to gather it up, and then it's going to push it back, and it's going to
Yeah.
cause that aircraft to go forward, which is going to give it that thrust.
Just like the balloon.
Just exactly like the balloon. Now I have one more part of the plane that I want to show you. All right, so here we are sitting in an authentic A320 cockpit. So what do you think?
Yeah, this is really cool.
A lot of buttons in there. Yes. So I just want to recap with you about all the things when it comes to the 4 forces of flight.
Weight,
Weight, which is going to be that downward pull.
lift,
Lift, which is going to be the opposite of weight, and you're going to have that upward,
drag,
which is going to go that air resistance against you and slow you down.
and thrust.
Thrust, which is going to do the opposite of drag, and it's going to propel or push you forward. So, what do you think?
Yeah, this is great. This is actually, this is a lot for only 4 things. So,
But the science behind it might be very basic, but it's also complicated as well. Yeah.
Thank you so much for teaching me this, Jessica. I can't wait to get on my first flight.
Don't forget to send me a postcard.
Not every Airbus employee works on the production floor, but no other job impacts what happens on the final assembly line more than logistics coordinators. We serve as the operational nerve center for the entire A320 assembly process. This means we track and trace every physical part coming to Mobile from all over the world. We also handle the documentation for ordering parts, as well as the planning for consumables, safety stock, and free materials inventories. Logistics coordinators also create, negotiate, and establish the planning processes with Airbus global vendors and stakeholders for both the A320 and A220 aircraft families. We coordinate the reassignment of aircraft parts and any rework or concession parts that may need to be acquired. This means lots of paperwork, computer screen time, and attention to detail. Preparing purchase orders, ensuring delivery schedules, material forecasting, and reviewing which parts and supplies have been used so we can order more. We work very closely with production, engineering, supply chain, and information systems as a multi-function team. We are the first point of contact for operations about any planning or logistical issues. To become a logistics coordinator, you need to have a bachelor's degree or a combination of education and work experience in industrial engineering, business administration, or supply chain logistics. A minimum of 3 years work experience is also required within the aviation industry. However, experience and education requirements may vary. With over 3 million parts to track for every A320 aircraft, being a logistics coordinator is one of the most important and challenging roles it takes to build the aircraft. Maybe it's a role that interests you.
My name is Anusha, and I was wondering, how much does the sky weigh?
The sky is not weightless. It is much heavier than you think. The sky is made of air, and the air is made of all kinds of gas molecules. The gas molecules have weight. Earth's air is around 78% nitrogen molecules, 21% oxygen molecules, and the rest are other gases. Scientists weigh air by measuring how much it presses against objects on Earth. So an average spot on Earth, the air is pressing against you with about 14.7 pounds of force. What does that mean to you? Pick up a dumbbell that weighs 15 pounds and you can see that air packs a significant force. Interestingly, the higher we go in altitude, like the mountains, the thinner the air gets and the less force it has. This means that the sky weighs 14.7 pounds per square foot inch of Earth's surface, which is roughly 1.2 quadrillion pounds. Luckily, the weight is distributed all over the Earth.
FlightWorks Alabama is a learning center that is a partnership between Airbus and the state of Alabama. I was a teacher for 11 years and I got my master's degree in STEM education. As a science teacher for 11 years, I constantly heard students and teachers saying if I had the more hands-on learning experiences, just like what you're teaching, I would probably go far in science, or I would keep going with science. And so what turned me from teacher to director of education is to teach those teachers, or to teach the students that come through here, that STEM education is important, and so is manufacturing, that there are different paths. Whether it's college or career, you have options when it comes to STEM. There are so many job opportunities when it comes to aviation, and when people think of aviation, they automatically think of pilots or flight attendants or jobs like that, but you have those manufacturing jobs that are behind the scenes where you are actually building these aircraft and you have the opportunity to make the aircraft different using what you learn. The most unbelievable thing when it comes to my job is how much goes into making an aircraft. I used to fly all the time, but to actually sit on an aircraft and look around and look at the wiring and the fuselage pieces and everything, and the riveting, the fasteners and everything that goes into it, that goes around you, that is probably the biggest wow. Like, I've always thought of aircrafts, oh, I know it's a lot to put together, but I didn't know exactly how much. It takes an entire world to build an A320. If a middle schooler came to me and started talking about, oh, I'm thinking about being an engineer or going into aviation, do it. There's not just one job when it comes to it. There's multiple engineers, and there's multiple things that you can do when it comes to this job. Whether it's painting an aircraft or building the aircraft or building parts for the aircraft, we need these fresh minds and fresh skills that come with students. There's so many wonderful things I love about my job. I love the fact that it's always different. There's something new to learn every day, whether it's with aviation or manufacturing or just with the students that come in. Everybody's always doing something different when it comes to FlightWorks.
Thanks for watching Alabama STEM Explorers. If you missed anything or you want to watch something again, you can check out our website at alabamastemexplorers.org. Maybe you have a question we could answer here on the show, and you might grab a cool t-shirt. Feel free to send us a video question or an email on our website, alabamastemexplorers.org. Thanks again for watching. We'll be back next week.
Alabama STEM Explorers is made possible by the generous support of the Hudson Alpha Institute for Biotechnology, translating the power of genomics into real-world results. Southern Research, solving the world's hardest problems. The Hawley Family Foundation, established to honor the legacy of Brigadier General Everett Hawley and his parents, Evelyn and Fred Hawley, champions of servant leadership. Alabama Works, a network of interconnected providers connecting business and industry needs to a highly skilled and trained workforce. Alabama STEM Council, dedicated to improving STEM education, career awareness, and workforce development across Alabama. Alabama Mathematics, Science, Technology, and Engineering Coalition for Education, advocating for exceptional STEM education in Alabama. Alabama Math, Science, and Technology Initiative, the Alabama Department of Education's initiative to improve math and science teaching statewide.